the Liskov substitution principle, or the L in solid. So the Liskov substitution principle sounds pretty simple, but in fact, it is one of the things that contributed to Barbara Liskov winning a Turing Award for her work on many aspects of object-oriented design. And the simple idea here is that substitutes or subclasses should be able to substitute for base types in an object-oriented system. If a method that works on an instance of type T should also work on any subtype of type T. And what we mean by subtypes, especially in Ruby, is not necessarily a strict parent-child inheritance relationship, but types as in a category of objects that operate the same way. So in Ruby, right, things that are enumerables that have subclasses should work with subtypes of enumerables. And the idea here is that as we get more specific, our object-oriented model should not require adaptations to the parent class. And so we'll talk about this. The Liskov substitution principle is one of those things that seems really simple in practice, but until someone created the idea, it became really easy to create subclasses in an object-oriented design that essentially overrode too much of their parent class's behavior. And we could sort of see that if we're not careful and we start talking about formatters that inherit, those specifications, by creating too much specificity in a subclass, mean that it actually can be quite difficult to swap out one subclass for another. And so what we'll look at are various tools for addressing this. The first idea are what can loosely be called contracts. And again, what we're going to do is compose smaller classes rather than inherit them. The idea is that if we can't express consistent assumptions between two different subclasses, this likely suggests some violation of the Liskov substitution principle, which is basically saying these two subclasses seem similar, but in fact, they have two different implementations. A really sort of simple example might illustrate this, right, is if you're implementing shapes as objects in a system, you might think about, well, all right, a square and a rectangle, they're two four-sided shapes, they all have 90-degree angles. Maybe a square should be a subclass of a rectangle because it is a rectangle with more specific constraints. This might be natural until you start implementing methods like, let's say, you want a method on a rectangle like make twice as wide as high, which is perfectly valid for a rectangle, but doesn't apply to a square. And now we have a method on a class that doesn't make sense for a subtype. What should make twice as wide as high do for a square? It's an invalid method. And so in this case, how might we resolve this? Well, we could compose two classes together where we could provide functions like area, width, height, and so on that might exist on a rectangle, and a square could leverage some of those, but not necessarily through inheritance.